On a quiet morning, way back in 1908, deep in the heart of Siberia, the Earth trembled. A blinding flash lit the sky. And then this massive shockwave just rolled across the taiga, flattening forests for miles around. When the dust finally settled, something like 2,000 square kilometers of wilderness were just devastated. And yet right at the epicenter, there was no crater. Nothing. So what unleashed that kind of power? Was it some kind of cosmic visitor? A secret weapon test, maybe? Or, something even stranger? Tonight, we're journeying right to the edge of science and mystery, the Tunguska Event. For you, our listener, we've gathered the accounts, the scientific research, and, well, the many theories that have sprung up. Our mission for this deep dive is really to unpack this century-old riddle, to try and understand not just what happened, but why it remains so compelling, what truly shook the Earth that day, and maybe what lessons did it teach us. Okay, so the date was June 30th, 1908. We're in the vast, very remote Siberian wilderness, specifically near the Podkamenaya-Tunguska River. And for the local Levaniki people and the few Russian settlers there, the day was just beginning.
Completely ordinary, by all accounts. A typical quiet summer morning in the taiga. But then, just suddenly, with absolute no warning, the sky violently erupted. Witnesses later described this terrifying bluish light. They said it was nearly as bright as the sun, streaking across the heavens. And this was followed by an intense flash, like a blinding burst of light, and then a pillar of fire rising impossibly high over the forest. The power unleashed was just immense, immediate, and utterly terrifying for anyone nearby. The shockwave that followed was so strong, it literally knocked people off their feet, even miles away. Windows shattered in distant settlements, glass just raining down, and a hot, searing wind raced through the forest, scorching everything. The sheer scale of this is hard to grasp. The explosion itself was reportedly heard over 1,000 kilometers away, and its seismic tremors, they actually registered on instruments right across Eurasia, a clear sign of its raw force. There's one particular eyewitness account from a man named S. Semenov. It paints a really vivid, chilling picture. He said, "The sky split in two, and fire appeared high and wide over the forest."
At that moment, I became so hot that I couldn't bear it, as if my shirt was on fire. Then the sky shut closed, and a strong thump sounded, and I was thrown a few meters. I mean, imagine that. That sudden, unbearable heat and a force that could just throw a person through the air. It's unimaginable, really.
It really is. And what's scientifically fascinating about these accounts is just how immediate and widespread that sensory impact was. Even in such a remote area, so many people saw, felt, and heard something so profound. It immediately signaled that this wasn't just, a local wildfire or something mundane. This was completely unprecedented. It tells us the energy released must have been absolutely colossal, traveling vast distances through the air and even through the Earth itself.
So when scientists finally managed to get to the site, and we should stress, it took years, didn't it?
Oh, yes. Years, largely because of how remote the region is, plus all the political turmoil in Russia at the time. Access was incredibly difficult.
Right, so when they finally got there, they found this scene of just utter, almost unbelievable devastation. Picture this, a vast expanse of forest, something like an estimated 80 million trees all knocked flat, and they were felled in this clear, radial pattern, stretching outward from a central point, almost like spokes on a wheel. These trees were scorched, stripped bare of their branches, just a silent, stark testament to the immense heat and force involved. But here's the thing, despite all that destruction, they found the central Enigma, the really perplexing clue. No impact crater. There was no gaping hole, no obvious point of collision with the ground. And the blast zone itself, it covered over 2,000 square kilometers, which, to give you some perspective, is an area larger than, say, Greater London. It's huge. And the effects weren't just confined to Siberia either. For days afterwards, the night skies across Europe glowed with this eerie, almost surreal light. People in places as far away as Scotland and Sweden reported being able to read newspapers at midnight, just by this strange light in the sky.
The scientific thinking now is that this was caused by sunlight reflecting off high-altitude ice particles and dust. Basically, tiny particles thrown way up into the upper atmosphere by the explosion, forming this sort of global dust veil. Which then, beautifully but eerily lit up the night sky long after sunset for people thousands of kilometers away.
So that lack of a crater, that was really the first major clue, wasn't it? It immediately told scientists that this couldn't be a conventional meteorite strike, the kind that digs a big hole in the ground. And what's truly fascinating is how the physical evidence itself really shaped the early theories. You had that combination. The massive radial tree fall, which clearly indicates a powerful blast from above, not from ground level. Coupled with the complete absence of a ground crater, it strongly pointed towards a very specific kind of event, an atmospheric explosion. This pattern, it really forced scientists away from standard terrestrial explanations and towards something, well, quite different. It fundamentally changed how we thought about cosmic objects hitting Earth.
Exactly. So with all this evidence, the immense destruction, no crater, those weird glowing skies, the central question becomes, what on Earth, or maybe off Earth, could cause such devastation without leaving that expected trace? Okay, let's talk theories. The leading one, the explanation most scientists lean towards today, is a meteorite or asteroid airburst. The idea is that a stony asteroid, maybe 50 to 60 meters wide, something like that.
Roughly, yes. That's the general estimate based on the energy calculation.
Right. It entered Earth's atmosphere at incredible speed, maybe close to 27 kilometers per second, just mind-boggling velocity. And as it plunged downwards, the immense heat and pressure building up just caused it to violently explode. But crucially, this happened high above the surface, somewhere between, say, 5 and 10 kilometers up. It didn't make it to the ground intact. The energy released in that mid-air detonation was, well, colossal. We're talking the equivalent of somewhere between 3 and maybe even 30 megatons of TNT.
Which is difficult to really visualize, but compare it to the Hiroshima bomb, this was potentially up to 1,000 times more powerful.
1,000 times. Wow. And that resulting shockwave was what flattened the forest below in that characteristic radial pattern. And because the object basically disintegrated, vaporized in midair, it just unleashed its destructive energy downwards. No solid body was left to hit the ground and form a crater. There's a quote from Christopher O. Johnston at NASA. He said something like, "The resultant shockwave and heat blast most likely correlate with the eyewitness reports and with the destruction described by later expeditions."
Yeah.
It seems to tie the observations together quite neatly, doesn't it?
It does. And this theory, it didn't just explain Tunguska. It really changed our whole understanding of atmospheric entry events. Before Tunguska, the main worry was always about ground impacts, craters. But this showed you could have immense devastation without a crater. It completely altered how we assessed the risk from smaller space objects, you know? It forced a rethink of the entire spectrum of cosmic threats.
Okay, so that's the leading theory. But there's an alternative, one that also gets serious consideration. The comet hypothesis. This suggests the object wasn't a rocky asteroid, but a comet, basically a big snowball of ice and dust. And this idea, it actually lines up quite well with some of the evidence, right? Like the lack of meteorite fragments.
Exactly. That's a key point. Despite extensive searches over the decades, no definitive fragments of the impactor have ever been confirmed. A comet, being mostly ice and volatile materials, would vaporize almost completely upon entering the atmosphere and exploding. It would leave very little physical evidence behind, which fits the observations rather well. It helps explain that sort of ghost-like nature of the event, immense power, but hardly any tangible leftovers.
And maybe it also explains the atmospheric effects better. The glowing skies.
Possibly. Comets are rich in water, ice, and dust, which, when blasted into the upper atmosphere, could certainly contribute to those persistent noctilucent clouds or similar phenomena observed over Europe. So yes, it offers a potentially better fit for some aspects.
Then there's a more recent idea, quite intriguing, called the bouncing asteroid theory. This one proposes that maybe an iron asteroid didn't just explode, but actually skimmed through the upper atmosphere. Perhaps shed some mass or energy via an explosion and then sort of skipped back out into space.
It's a novel concept. The idea is that a body strong enough, like iron, hitting at a very shallow angle, might survive atmospheric passage, cause the observed blast wave, and then continue on its trajectory away from Earth. It tries to explain the lack of a crater and fragments by suggesting the main body never actually stopped here.
But how plausible is that, physically speaking?
Well, that's where it gets challenging. The physics involved, the specific angle of entry needed, the mechanics of surviving that passage and bouncing it requires a very precise, perhaps unlikely set of circumstances. So while it's an interesting thought experiment that addresses the core mystery, it introduces its own set of, let's say, significant physical hurdles that the scientific community is still debating. It's not widely accepted currently.
And of course, with any great mystery, you get the wilder theories too. Over the years, people have suggested everything from, I don't know, a secret weapon test gone wrong.
Which seems incredibly unlikely given the era and the scale.
Right. Or even stranger ideas, like a miniature black hole passing through the Earth. Or, perhaps inevitably, alien intervention. There was a researcher, Yuri Labman, wasn't there, claiming unusual quartz crystals pointed to a UFO explosion.
Yes, those claims have been made. But it's crucial to state that mainstream science finds absolutely no credible evidence to support these more, shall we say, exotic explanations. The scientific method relies on empirical evidence, on testable hypotheses, and these ideas simply don't meet that standard based on what we found at Tunguska.
But it is interesting, isn't it, why these more sensational theories often grab the public imagination so much, even with little or no proof.
It is. I think it probably speaks to our human desire for narrative, for clear answers, especially for something so dramatic. Science often deals in probabilities, in uncertainties, in complex models like an airburst. That can be less satisfying, maybe, than a dramatic story involving aliens or secret government plots. It offers a simpler, more direct explanation, even if it's not supported by the facts. It's the allure of the extraordinary, perhaps.
So even now, despite, more than a century of research, over 1,000 scientific papers published, some basic questions about Tunguska still linger. We still haven't found those definitive, unambiguous fragments of the object, which means the exact nature of that cosmic visitor, stony asteroid, icy comet, something else entirely. It's still technically debated, right?
That's fair to say. The exact composition remains elusive because we lack that direct sample. The consensus leans heavily towards an air-bursting asteroid, or possibly a comet, but without those fragments, there's still room for discussion on the specifics.
Yet, despite those unknowns, the overall scientific picture is pretty clear. Most experts agree. The Tunguska explosion was, almost certainly, the largest impact event on Earth in recorded history. A truly singular, devastating moment.
Absolutely. And connecting this back, Tunguska wasn't just some historical curiosity. It was a profound wake-up call. It served as this stark, undeniable reminder that Earth is vulnerable to hazards from space. We aren't isolated. This event really galvanized efforts towards what we now call planetary defense. It led directly to programs designed to find and track near-Earth objects, asteroids, and comets that could pose a threat. It shifted the discussion from purely theoretical impact scenarios to practical, proactive steps for monitoring the skies. So in a very real sense, Tunguska transformed a potential risk into an urgent, tangible concern for all of us. Leonid Kulik, he was the first scientist to actually lead expeditions to the site, facing incredible hardship. He put it very well. He essentially said, the Tunguska event is a warning from the cosmos, a demonstration of the power that lurks in the void above. It just underscores why understanding and tracking these things isn't just science fiction, it's crucial for our planet's long-term security.
So, was it an asteroid? A comet? Or something else, still just beyond our complete grasp? The vast Siberian wilderness, it seems, still holds on tight to some of its secrets from that morning. The Tunguska event remains this profound riddle. A single devastating moment when the sky fell and the Earth, at least in that remote corner, was irrevocably changed. It's a powerful reminder, isn't it? That our planet is part of a much larger, dynamic, and sometimes dangerous cosmic environment. Until we know for sure, until maybe someday those definitive fragments are found, the mystery endures, waiting perhaps for the next cosmic messenger, hopefully a much smaller one, to arrive. We hope this deep dive has given you some new insights into one of Earth's most enduring cosmic puzzles, and may, just maybe, sparked a renewed sense of awe at the vast, mysterious universe all around us.